In this section, we're going to talk about how to divide polynomials with both long and synthetic division. And we're also going to talk about how to use those in order to factor polynomials that we can't factor by grouping or by asterisk method. So let's go ahead and jump right in. You're going to be writing down a few step-by-step notes, so get ready to pause the video so that you have the time to do that. So first of all, with long division, you want to make sure you arrange the terms in order from least to greatest exponent. So the power should descend. Then you're going to divide the first term in the dividend by the first term in the divisor, and that is the first term of the quotient. In other words, you're going to find what you have to multiply the inside of the house by to get the outside of the house. Then you're going to multiply every term in the divisor by that value, and you're going to line everything up underneath. You're going to subtract the product from the dividend, and what I'm going to add here is you're going to change all signs and add. I find that a much easier way to do this. Pause the video if you need to catch up. Then you bring down the next term and you're going to repeat the process until you can no longer divide, and you're going to have a remainder some of the time. Sometimes you'll have a remainder of 0. You'll know that you can stop when the degree of the remainder is less than the degree of the divisor. Okay, so if at any point what you've carried down is the same degree or higher, you should keep going. Again, pause if you need. All right, then if f of x and d of x are polynomials where d of x is not 0, okay, keep that in mind, all right, because you can't divide d of x, you can't divide 0, then we can say that f of x equals d of x times q of x plus r of x, okay, where q is the quotient and r is the remainder. All right, so this is not the most intuitive way to write it, but the idea is if I can, okay, so let me write it like this. I could divide everything, okay, by d of x all the way through, okay, and the d's would cancel here, so we were saying that f of x divided by d of x equals q of x plus r of x divided by d of x. Okay, so the remainder is going to go over top of what was already in the denominator, and q of x is what's left over top of the house. The reason why we also think about it this way is because sometimes we need to pseudo-factor things. This is only kind of factored because it does have the remainder in it, but if the remainder is 0, then it factors out perfectly, and that's going to help us find zeros of the function. Don't worry if this confuses you, because bear with me, we're going to do some practice problems. You're going to be like, oh, that. So let's start by doing some long division. If we have 7 minus 11x minus 3x squared plus 2x cubed, and we want to divide it by x minus 3, the very first thing you have to do is make sure to rewrite the top of your division by order of the exponent. So you should start with the biggest exponent and work your way down. Then once you've done that, you're going to be able to say, now we're really dividing 2x cubed minus 3x squared minus 11x plus 7 by x minus 3. And this is going to be much easier to work with. Now, the big thing is going to go under the house, and the little thing, what we're dividing by, goes outside of the house. Okay. Now, I want to figure out, what do I multiply x by to get 2x cubed? Well, that's going to be 2x squared. So you'll notice I write this over the second term. The reason why I write it over the second term is because I have 2 terms. So when I'm multiplying 2x squared, I'm going to have 2 terms, and I want to make sure I write it underneath. Okay, so 2x squared, and then I'm going to distribute that, so I'm going to multiply everything through by that, and that's going to give me 2x cubed minus 6x squared. Now, we want to subtract this, so keep in mind, when I subtract, what I'm doing is I'm changing the signs. So what was positive is now negative, what was negative is now positive, and I'm adding down. That's how I'm doing the subtraction. My first term should always cancel. If it doesn't, you want to try again. Okay, and then I add down, I get 3x squared, and I carry down my negative 11x. Now I want to repeat the process. I want to ask, what do I multiply x by to get 3x squared? Well, I need to multiply by 3x, so I write plus 3x. Again, notice here that it's plus 3x, not just 3x. Okay, that's important because you have to have a sign between the two terms. Now, when I distribute 3x, okay, then 3x times x is 3x squared. 3x times negative 3 is negative 9x. I can line that up. Then I have to change the signs. Now that I've changed my signs, I can add down. And I'm also going to carry down my 7. Now I want to know, what do I multiply x by to get negative 2x? Well, that's just going to be a plain old negative 2. When I distribute that, I'm going to get negative 2x plus 6. Then I have to change my signs and add down. So you'll see here that after all of that, I have a remainder of 1, and I have to stop here. 2 ways I know that I'm stopping. First of all, what I have left over is a smaller degree than what I have over here. So x minus 3 can't go into 1 because this is degree 0, and that's degree 1. So again, the number 1 is degree 0 because it has no x, whereas x minus 3 is degree 1 because it's x to the 1. All right? Now, if I have done my long division correctly, I can now write this out in a divided format. So when I get my answer, I take what's on the top, all right, and that becomes my first part here. And then my remainder becomes the top of the fraction. And what I divided by is the bottom of my fraction. So this is how we take what's in our long division and write it out in that format we were talking about earlier. Now, synthetic division is another way to do division that's maybe a little less messy. However, it's a little tricky in the sense that you can only do it some of the time. But let's go through the steps. First thing you're going to want to do is arrange the polynomial in descending power. So biggest exponent first, just like the last one. Okay? And if there are any missing terms, you put a placeholder in its spot. Okay? So if you, for example, don't have an x squared, you put a 0 where the x squared would go. Now, we're going to write C for the divisor of C in a little box, okay? And then we're going to write the coefficients of the dividend next to it. So you're going to write your C here, and then you're going to have your coefficients written out here, okay? Then you're going to write the leading coefficient of the dividend on the bottom row. So you're going to carry the first one down. Then you're going to multiply C by that number. And you're going to write it right here. And then after that, you're going to add down. Pause the video if you need to catch up. Now we want to add the numbers in that column, and we want to repeat. At the very end, the numbers that are under that line are going to be how we translate to our new polynomial, our what we divided to. So for example, let's say I had 2, 4, and -1, and then I had a 6. And that tells me my answer is 2x squared plus 4x minus 1. And then it would be 6 over whatever I was originally divided by. So your last number is the remainder. The rest of the numbers are your coefficients. I'm going to give you an example of this. Let's take a look at this one here. Let's use synthetic division to divide x cubed minus 7x minus 6 by x plus 2. Okay, I'm putting parentheses around it just so you can see where each thing ends. Now, first thing we're going to do, well, you're going to notice that this is long division notation. We're not actually doing long division. Don't freak out. But what you want to do is you want to make sure that you're putting it in order. So x cubed comes first. Then we normally have x squared. But it's 0x squared this time because there is no x squared. So again, you need to make sure you have the 0x squared here. Then we have minus 7x and minus 6. You'll also notice that x plus 2 is really x minus -2. So my c value is -2. Another way to think about it is c equals what makes the parentheses equal 0. So in this case, -2 would make that equal to 0. That's why we get -2 for c. So we're going to go ahead and write this out. -2 goes in my box, because again, that's what makes this equal 0. And then I have my coefficient. So 1 is in front of my x cubed. I have 0x squared, so I have a 0. -7x means I write down my -7, and then I have minus 6. Okay? So again, keep in mind, c value goes in the box. Write out the coefficients next to it. You're going to carry the 1 down. Then you multiply. 1 times -2 gives you -2. Okay, so again, -2 times 1 is -2. Then we're going to add these two. So -2 times 1 is -2. 0 plus -2 is -2. -2 times -2 is 4. We add down. -7 plus 4 is -3. Then I multiply again. -3 times -2 is 6. And I add those together and I get 0. Now, that means this is the remainder. That means the remainder is 0. There is no remainder. My original thing that I had was a cubic. It had a degree of 3, x cubed. Okay? So my answer is going to be a degree 2. It's always going to be 1 less. So this is 1 goes with my x squared. -2 goes with my x. And -3 is my plain old number. So that's why it's 1x squared minus 2x minus 3. And notice that we don't actually write the 1 here. Now, let's say we have a remainder, okay? So the polynomial f of x is divided by x minus c, then the remainder is f of x. So what do I mean by that? Well, let's take a look at this function here. I want to use what's called remainder theorem, what we're talking about, to find f of -4. The good news is that this is actually a super easy way to evaluate functions at values. Okay, if I wanted to find f of -4 by what's called direct substitution, I would plug -4 in for each x value. However, that gets a little messy because you're doing -4 cubed and then you have to multiply by 3. You have to do -4 squared and multiply by 4. These numbers start to get rather large rather quickly. So instead, what I'm going to do is I'm not going to change the slide this time. I'm going to use synthetic division. So -4 goes in my box. My order is already correct. So I have an x cubed is 3. My x squared has a 4. My x has a -5. And my plain old number is a 3. So when I use synthetic division, I carry down my 3. I multiply by -4, so that's -12. Then I add down and I get -8. When I multiply by -4, I get 32. I add that to -5, and I get 27. I multiply that by -4, and I get -108. And then I add down and I get -105. That means that f of -4 equals -105. So whatever your remainder is when you do synthetic division gives you the value of the function at that number. Pretty cool. Now, if f of x is a polynomial and we know that the function equals 0, then x minus c is a factor of f of x. Now, I normally write this as f of c equals 0. I find that's easier for me to remember what's going on. So if you know plug in c, you get 0, then x minus c had to have been a factor of f of x. And if x minus c is a factor of f of x, then by definition, f of c equals 0. So in other words, it works both ways. So this is a way that we can factor polynomials that are maybe a little harder for us to factor. Maybe we can't factor by grouping, or maybe we can't factor by asterisk method. Maybe it's a quartic function or a quintic function. Factor theorem is going to let us do the factoring. So we want to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that -1 is one of the zeros. Okay, I want to point out to you that if I tried to factor this, it wouldn't be factorable by grouping. So it comes out kind of messy if I try that. So instead, since I have -1 as a 0, I can say that f of -1 equals 0. And because f of -1 equals 0, then I know that x minus -1, which happens to be the same thing as x plus 1, is a factor of f of x. So I'm going to be able to use that in order to factor out x plus 1 is what I'm saying. So I'm going to be able to do, f of x really equals x plus 1 times something. Okay? So first of all, what we're going to do? Well, we're going to use synthetic division because we can. And we're going to plug -1 into my box because, again, that's my 0. I write out my coefficients, which are 15, 14, -3, and -2. I carry down my 15. You know what? Try this on your own. Pause the video. See if you can finish the synthetic division. Okay, so I multiply, I get -15. I add, I get -1. Multiply, I get +1. Add, I get -2. Multiply, I get 2. Add, I get 0. And this is my remainder. And remember, since I told you it was a 0, the function, it has to be 0 at the end in the remainder. Otherwise, it didn't go right. Now, I told you on the previous slide that I'm going to be able to write f of x as x plus 1 times something. Well, now I know what the something is, okay? Because when I divided by x plus 1, I got this 15x squared minus x minus 2. So I can write my f of x equals, and instead of writing it in the cubic form, I have my x plus 1 times 15x squared minus x minus 2. So again, what I did there was because I divided by x plus 1, what I have left is what I would have left if I factored x plus 1 out. Now, remember that the original question wants us to solve it when it equals 0. Well, in order for me to finish solving it, I had to finish factoring it. So I want to factor 15x squared minus x minus 2. Okay, so just a quick walkthrough how this factored into these two things. If you used your asterisk, a times c is -30, b is -1, a is 15. There are two numbers that multiply to -30 and add to -1. They are -6 and +5. 15 over -6, you can divide each one by 3, and you get 5 over -2. 15 over 5, you can divide both by 5. That's 3 over 1. So you notice I have 5x minus 2, and I have 3x plus 1. Order doesn't matter as long as the 3 and the 1 go together and the 5 and negative 2 go together. Now, I finished factoring. It doesn't factor anymore. And because this equals 0, I can set each piece equal to 0. So the x plus 1 gives me negative 1. The 3x plus 1 gives me negative 1/3. The 5x minus 2 gives me 2/5. These are the 3 solutions to this equation. Try dividing this using long division. Make sure to put placeholders into anything that is missing. So I have 6x to the 4th plus 6x cubed minus x squared plus 0x plus 0. And I'm dividing by 2x squared plus 0x plus 1. If you got stuck because you didn't have placeholders, go ahead and fix that on your paper and try again. Okay, so this has 3 terms, 1, 2, 3. So I go 1, 2, 3 terms over. This is where I'm going to start, right here. What do I multiply 2x squared by to get 6x to the 4th? Well, 2 times 3 gives me 6. And if I have x squared, I'm going to have to multiply by another x squared to get x to the 4th. Now I multiply through. I get 6x to the 4th plus 0x cubed plus 3x squared. And then I have to change my signs all the way through and add down. That's going to give me 6x cubed minus 4x squared. And then I carry down my plus 0x. Now, I need to find what I multiply 2x squared by to get 6x cubed. 2 times 3 gives me 6, and x times x squared gives me x cubed. So now I'm going to distribute that. That's going to give me 6x cubed plus 0x squared plus 3x. I am once again going to change all of my signs. When I add down, I get negative 4x squared minus 3x. And I can carry down my plus 0. Now I need to figure out what I am multiplying my 2x squared by to get negative 4x squared. So again, 2x squared, negative 4x squared. So I have to do a negative 2. And again, I'm going to distribute. Okay, that's going to give me negative 4x squared plus 0x minus 2. I change my signs, and I get negative 3x plus 2. Now, I can't divide any more because what I have left in my remainder is a smaller degree than what I'm dividing by. So now I just need to go write my answer, and it's going to have a remainder, and that's okay. So I take what's on top of the house, and I write that down, and then I write a plus. My remainder goes on top of the fraction, and I was dividing by 2x squared plus 1, so I am still dividing by 2x squared plus 1. Ta-da! Now, try dividing this one using synthetic division. So, first of all, I look at what makes this equal to 0, and the answer is 6. Then I take the coefficients of my other set of parentheses. So I have 1, 9, negative 8, and 2. And I carry down my first number, multiply, add, multiply. Okay, 6 times 15 is going to be 90. Then I add down, I get 72. I multiply again, and I get 432. Yeah, 432, and I add down, I get 434. Okay? So now I can write my answer. I have 1x squared plus 15x plus 72. I'm sorry, that is so wrong. Y'all are probably going, what in the world? That's supposed to be 82, which means this is 492, which means this is 494. I'm so sorry. Okay, so plus 82 plus 492 over x minus 6. I really hope that's right now. Okay, hopefully that's good now. So that is synthetic division. All right, use synthetic division and remainder theorem to find f of 4. So remember, don't just plug 4 in. Use synthetic division to find the value. So 4 goes in my box, and my coefficients are 1, 3, 9, -5, and -4. Carry down my 1, multiply, add, multiply, add, multiply. That gives you 148. Add, multiply, 566. Guys, really? This is me checking because this is how it goes. Okay, 4 times 3 is 12, 16, 17, 572. Okay. See? No, it was not 566. 572. And then that gives you 568. Okay, so f of 4 equals 568. All right, solve this equation given that one of your zeros is 1. All right, so first of all, notice that since 1 is a 0, I'm going to be able to factor out x minus 1. And I'm going to have something here, and it's going to equal 0. Okay, so that's the goal, is to figure out what do I have when I pull out x minus 1. So I start by putting 1 in my box, and then I have my coefficient. So x cubed minus 13x squared plus 47x minus 35. Now I carry down my 1. I multiply. I add. I multiply. I add. I multiply. And I add. And the good news is it comes out to 0 like it's supposed to. So keep in mind, again, I was doing x minus 1 times something equals 0. Well, what's the something? Well, it's 1x squared minus 12x plus 35. Now I can factor this further, and so I should. So I have x minus 1, and I need to find two numbers that multiply to 35 and add to -12. Those two numbers are -5 and -7. So that gives me x equals 1, 5, and 7 as my 3 answers. Excellent job with that division.